Hi, this is Huda Zenham from 2212, Section P, and this is the first lab. To introduce, we have an experimental data which is determined to excess amount of charge on clear tape, and then we have some coding where we will write a program to determine the computational model of two charged tapes exerting an electric force on each other and the exerted gravitational force. With our analysis, we will observe how charge affects an object, visualize the interacting forces using experimental and computational data, and then relate the data to Coulomb's law using calculations. The process for the tapes is first fold the end of a strip of tape into a loop, and this will be our Utape, seen in the first picture. Then we will place it on top of another strip that is on a flat surface and quickly pull the Utape off the base tape, shown in the second picture. Rub a plastic pen on it to see that it is negatively charged, and then repeat steps 1 to 4 to have two U-tapes. Then we will hold one U-tape on top of the other so that the top one floats, and thus showing the repulsion between them since they have like charges, shown in the third image. So some observations that we will note. The U-tapes repel one another because they are both negatively charged, as stated before, and the top one floats upward because the bottom tape is exerting electric force. We will ignore air resistance, and the tapes hold the same amount of charge, and the tapes act as point charges. For our recorded data, we have the length and width of the U-tapes and the distance between the tapes. We have a gravitational force, which is negative mass times gravitational acceleration, and a surface area, which is length times width, and the number of atoms, which is the surface area divided by atom length squared. For our physics calculations, we see here that using Coulomb's law, we will use the gravitational force and distance to find Q, which is a charge. Here is the equation we will use. And in this scenario, we're going to replace Q1 times Q2 with just Q squared because, as stated before, they have the same charge. A force property will let us know that the electric force on B by A is just negative gravitational force because those forces are equal yet opposite in magnitude. The charge on the tape will be determined by isolating Q using this equation as stated before, and that will give us the charge. Then we have excess electrons, which is the tape charge divided by the electron charge. And then we have the ratio of excess electrons to atoms, dividing electrons divided by atoms. So for our computations of the code, we have to set initial values. We have the K value, the charge of an electron, gravitational constant, the mass of the tape, the length of the tape, and the distance between the tapes. And for our calculations, we will do all of the calculations shown before, such as the tape charge, the excess electrons, number of atoms, and the ratio. And then we have to show two spheres, the top one indicating the top tape and the bottom one indicating the bottom tape. And then we have two arrows here. The bottom arrow is gravitational force, and the top arrow is the electric force. As shown before, using our properties, we know that these are equal and opposite, and now we can visualize that. So for some questions that will help us think about the situation, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? They would still repel each other because of like charges, because it doesn't matter if they're both positive or negative. As long as they're the same, they will repel each other. If, let's say, then they were opposite, they would then attract each other. It doesn't matter what the charge is. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? Tapes could lose the excess electrons it holds to other objects because of the interactions they have with them. So to gather the most accurate results, we want to have the least amount of interactions as possible, isolating the tapes and making sure that they aren't having any contact with anything else that could affect your results. Thank you and have a good day.